Okay. All right, guys. So I hope my screen is visible, right? Fine, great. So what we'll do, okay, today we have to see the Windows rank functions, right? Windows rank functions we have to see today. So let me open the material. Okay. Windows functions 143. Yeah.
This
See here,
meeting is being recorded.
implementation of data flows with Windows and sync transformation. See here, guys, what is Windows functions that we'll see here first. Okay. See, a window function performs a calculation across a set of table. Okay, across a set of table of rows that are somehow related to the current rows. Okay, this is comparable to the type of calculation that can be done with an aggregate function, but unlike regular aggregate functions. Okay, and using of Windows functions does not cause rows to become grouped into a single output row. Okay, the rows retain their separate identities behind the scene, and the Windows functions can access more than just the current row of the query result. Okay, so what happened here? The different Windows functions we are having is like rank, dense rank, and row number. These are the different Windows functions we are having. Okay, so what is happening here? What data you are giving? What data you are giving to your Windows functions, to this Windows functions? Accordingly, they will generate the rank for the data. They will generate the rank for the data accordingly, the number of what you are giving to the Windows functions. Okay, so in Windows functions, to generate the ranks, we are having different functions and their different nature. Okay, each function is having a different nature. To generate the rank depends upon the data what we are giving to them. Depends upon the data what we are giving it to them. Okay, so what if you see here the rank function? If you see here the rank function, as the name suggests, the rank function assigns rank to all the rows within every partition. Rank is assigned, okay, such that rank 1 given to the first row and rows having same values are assigned same rank. For the next rank, after two same rank values, one rank value will be skipped. Okay, so if I show you the practical, it will be much more clear to you what I'm trying to say here. If any one particular record is having the same value, okay, then rank function will give the same rank to it, and the next immediate rank it will skip. It will skip the next immediate rank. This is what it is I'm trying to say. Dense rank. Okay. It assigns ranks to each row within partition, just like rank function. Okay. Just like rank function, first row is assigned rank 1 and row having same value, same rank. The difference between rank and dense rank, in dense rank, for the next rank after two same rank consecutive integer is used, no rank is skipped. It will not skip the rank if the row has got the same value. Practically, you see, you will understand much more better. Row number will generate the same rank for all the records irrespective of the value whatever it is. Okay, fine. So what I'll do, I'll start this lab implementation of data flow with Windows and Sync transformation. I think some people are okay. Fine. So we'll do the lab. It will be much more clear to all of you guys. We'll do the lab. It will be much more clear to all of you. So what I'll do, I'll say here implementation of data flows with Windows and Sync transformations. With Windows and Sync transformations. Okay. If you see here, step one, what it is saying, create an SQL database of AdventureWorks. AdventureWorks SQL database. It is asking us to create. Next, ADF. So let me log into the Azure portal here. Okay. SQL database is there. Yes, SQL database is there. Yesterday only we have deployed this SQL database. Right, guys? And this is AdventureWorks database only. Perfect. I'll take this one. Okay. Next, it is asking me to create an ADF link services. This link services, okay, for SQL database data set on top of this table. Okay, fine. So I will come here. I'll go to data factories. Okay, yesterday I have created this data factory. I'll launch the data factory. Manage. Okay, fine. I'm just doing a test connection so that the connections will get refreshed. Just hold on. Okay. So data set also I'll cross check once. What happened? Why it is taking this much long time? Okay, connection failed. Okay, connection successful. Okay, say here apply. Okay, this destination is not required. So I'll just delete the destination link services. I'll come here, data set. I'll take this data set. I'll say here edit. Okay, this is fine. This is my link services. Okay, and see this is the table, product table. So data set we have to create on top product table only. This data set ds underscore SQL we are creating on top of product table only. Exactly that is we are seeing here. Okay, product table. This is done. Then publish all publish. This data set is not needed destination data set. I'm creating this. I'm deleting the destination data. I'll say here publish. Okay, it's not working. So what we have to do, we have to delete this data flow. We have to delete this pipeline. Okay, fine. I'll say publish all publish. So the things which are not required, I have deleted. Okay, and I'm saying here publish and publish all. Okay, 1 minute. We'll do it again. See, publishing is completed. Publishing completed. This is done. Now, next, what it is saying, create a new data flow with this name, add source in source settings tab, and give this data set, enable data flow debug option, go to projection tab, import. Okay, I'll just do step by step. I'll say here new data flow. I'll say here df underscore data flow 1. I'll say here add source. I'll give this data set ds underscore sql. Okay, fine. Enable data flow debug option. This we have to enable compulsory. Okay. So next is what? Go to projection tab. So just hold on. Let this get enabled. Let this get enabled. Okay, we'll wait for it for some time. Okay, done. Data flow debug is enabled. Okay, this is done. And next, what we'll do? Okay, go to projection tab, import the projection. This is our projection tab, and say here import the projection. It will just refresh the schema of the table and its columns, table columns basically. Okay, so let it get imported. This is compulsorily we have to do, guys, because the things will get refreshed inside our source transformation from the SQL database table. From the SQL database table. Okay, is that clear? Okay, successfully imported data preview, and I'll take here refresh. Okay, Guys, tomorrow we are not having class. Okay. Tomorrow we are not having class. We'll connect again on Monday. Okay. Fine. Okay. Okay, na? Is this clear? Tomorrow is Sunday. Tomorrow we are not having a class. Okay. We'll connect again on Monday. Okay. Fine. So this is what the data we have got. Fine. What I'll do next. Okay. I click on plus on source transformation in search type window. Click on Windows transformation. Okay. I'll search here for Windows transformation. Okay. Windows transformation. Okay. In Windows settings tab, click on this one. Okay. In Windows settings tab, click on this. Okay. Over. For source one's column, choose size. Say here size. Okay. Click on to sort. Okay. This one. And for source one's column, standard cost. Okay. I'm generating the rank on top of these columns inside the table. Why I'm considering these columns size, standard cost? Because I'm generating my rank on top of these columns data. These columns are where? These columns are inside the table. Which table? Product table. The product is where? The product is inside the Adventure Works database. That's what we have created. Right now? Correct now? Yes or no, guys? This is what the database Adventure Works we have created. Okay. And this is the database we have created. Inside this database, we are having a table called products. All the links are connected, guys. All these things are connected here. Product. Okay. And if you see here, product table, select a star from dbo dot product. Okay. I'll say here run. Okay. Fine. No problem. It is saying this version is not supporting in the cloud platform. Okay. So I'll open it in SQL Server Management Studio. Okay. I will come here. I'll take this. Okay. I'll say here Gareth. I'll pass the user ID and password. I'll make a login to my cloud database and cloud server. Okay. Fine. So I'm having table here, product, right? Product. So I'll say here select star from dbo data. Okay. Products. Okay, sorry. This is not dbo. This is sales lt dot product. See now, here I'm generating the column. I'm generating the rank on top of this column, standard cost. See what I'm giving? Standard cost. See standard cost. I'm generating my rank on top of standard cost. Okay, this is the column in my product table. This table is in my Adventure Works database that we have created. Fine. That is what I'm trying to explain you guys. This is what I have done. Next, click on for window column. Okay, for column rank on left side, and in expression box type rank. Okay, so I'll say here this one. Okay, for this one, what it is asking for column rank on left side. If I'm having no, I'll say here rank, and then the expression. Okay, and in expression box type rank. Okay, on right side as shown below. So this is what something. This is a rank function. I'm calling rank function. Okay, click on Windows transformation data preview, refresh. Windows transformation data preview, take a refresh. Yeah, see here from the source transformation, the data is getting loaded into our Windows transformation, and we have considered what standard cost, right? This is the standard cost. So if you see here, the standard cost, this is having the same value 1.8663, 1.8663, 1.8663, same values, right? So for all these three records, okay, for all these three records, it will give the same rank. Okay, this is standard cost. Okay, standard cost, same value. If you go here, it will give the same rank. See, 333. This is our rank function. It is giving 333, same rank. And what it is doing, it is skipping the next immediate rank. 3, 4, 5. Right now, 3, 4, 5. So, because of the same value for our standard cost, okay, it that's why it is giving the same rank 3, 3. Then after that, it is skipping the 4, 5. It is giving the sixth rank to the next immediate record. This is what the rank function will do. This is what the rank function will do. Same way, if I come here, if I say here add column, if I say here dense rank, okay, I am saying next is what a dense rank, something like this, dense rank. I am just calling dense rank. Okay, I'll say data preview. I'll take a refresh. Now see what dense rank will do for standard cost. See, standard cost having the same value. Okay, so if you see here, dense rank, a new column got generated. Dense rank, a new column got generated. This is rank column got generated. This is dense rank got generated. If you see here for dense rank, see whichever records is having the same value, it is giving the same rank, but it is not skipping the next immediate rank. It is not skipping the next immediate rank. Whereas rank function is skipping the next immediate rank. It is supposed to give 4 here. It is not giving 4. What it assumes that whichever the records getting the same rank, okay, it will skip the next immediate ranks. Dense rank will not do like that. Dense rank will not skip the next immediate rank. If the records is having the same value, it will give the same rank, and the next record it will give the next immediate rank. It will not skip the next immediate rank. Guys, understanding or not? Clear or not? Okay. I am explaining without this one only, Nama, Ramya. Just for these steps, I am referring the document. Sometimes here I am explaining you. Is this not clear to you now, Ramya? Ramya, you there? Fine. Next, what I am doing here, I am taking row number function. Next is what? After dense rank, this is dense rank we are doing. Next we are having is what? Row number. See, row number function. This is also one of the Windows functions. This is also one of the Windows functions. So what I'm doing here, I'll say add column. I'll say here row number. I'm calling the row number function. I'm calling the row number function. What is the nature of row number function? You see now. So these are the different Windows functions, and every function is having its nature. And that is what the nature I am showing you live here in the implementation. Okay, I'll come to data preview. I'll take a refresh. Okay, this may ask in the interviews, guys. Please be careful. This will be asked in the interviews, saying that have you used Windows functions? What functions you have used? What is the purpose of these functions? Can you explain the difference between rank, dense rank, and row number functions? This is expected. So that's why I'm showing all these things to you. So now see what is the nature of row number function. This is our row number function. Row number function will not give the same rank to any record if the value is same. See here, row number function, row number function, okay, will not give the same rank, will not give the same rank to any of the records. Sorry guys. Sorry. So row number function will not give the same rank to any of the records, okay, though the values are same. Okay, row number function will not give the same rank to any of the records, though the values are same. So see here, is it giving any rank, same rank? Like see, this dense rank is giving same rank, 3, 3, 3. Why? Because the standard cost value is same. 1.8663, 1.8663, 1.8663. Okay. And what it is doing, though the value is same for all these three records, but still it is not okay, still it is not giving the same rank. That's what I'm saying. Row number function will not give the same rank to any of the records, though the values are same. What dense rank is doing, okay, I'm writing in a very simple words now. Okay, dense rank, okay, function will give the same rank, okay, will give the same rank to all the records which are carrying the same value, which are carrying the same value, and also it does not skip the next immediate rank. Okay, correct. It will not skip. After 333, it is giving 4. It is not skipping. Whereas rank function, what rank function will do? Rank function, okay, will give the same rank to all the records which are carrying the same values. Okay, but it will skip the next immediate rank. In simple words, I'm giving these definitions, guys. Okay, fine. Clear? This is rank function. This is dense rank function. This is row number function. That is what I want to show here. Okay, fine. So click on Windows Transformation Data Preview. You will see for rank, dense rank, and no number function like this. See here I am highlighting also in the image. Here I am highlighting as well. See what I am saying here in the image. See, rank is skipping. Rank function is skipping the ranks immediate rank. Okay, it is straightforward giving 6. Dense rank function is giving 4. It is not skipping the ranks. Row number function, okay, will give a unique rank irrespective of the data, whatever it is. Okay, fine guys. This is what about the, okay, Windows transformation in Azure Data Factory. Fine guys. Next we are having is what are the disadvantages of using traditional frameworks? Okay, traditional frameworks, what are the disadvantages? But I'll let you explain. So this is the end of Data Factory, guys. Here we have completed Azure Data Factory. Okay, from here we'll discuss little about the old traditional technologies, what are the disadvantages, and why we started using Databricks. Why we started using Databricks, that we'll discuss. Then I'll start the labs for Azure Databricks. I'll start the labs for Azure Databricks. So see here, big data or Hadoop. Okay, what I'm trying to say here, big data or Hadoop carries huge volume of data. Here we try to process huge volume of data, okay, in our real-time projects, okay, using big data and Hadoop technologies. Spark is being used by everyone nowadays for doing the transformations. And before Spark, we have Hadoop, and Hadoop is one of the solutions for big data. And when we want to handle huge volume of data, then we use Hadoop framework only. When we are having huge volume of data, we use Hadoop frameworks only. Earlier, to handle the big data, we use Hadoop, and it is HDFS, Hadoop Distributed File System, plus MapReduce. We can use Hadoop for loading the data and MapReduce for processing the data. We are using Hadoop to load the data and MapReduce for processing the data. Previously, before Databricks in the year 2017, 18, okay, 19, like that. Now we started using Databricks. Hadoop is one of the solutions for big data. We can use HDFS, Hadoop distributed file system, to load any kind of data, and that can be generated from many different kind of sources and can generate any kind of data like below. Structured and semi-structured data we can, okay, load, we can process using Hadoop and MapReduce. Okay, so this data will be generated from variety of different kind of sources, and MapReduce is a framework where we can do the transformations. We can use this MapReduce for doing the transformation using Java language. We should be having little knowledge of Java, okay, when we want to perform any kind of transformations. And while doing transformation actions, like when we have mappers and reducers, where we can perform the transformations, and for each mapper and for each reducer we can able to load the data in hard disk. Okay, so MapReduce we are using to load the data into the, okay, hard disk, into our destination, whatever you can say. Loading the data in hard disk is a costliest operation. So when we are using MapReduce, when you are using big data, Hadoop, then it was going a costliest operation. it takes time to load each and every time. It was taking lot of time to load the data. It is going costly. Okay, and every time it is taking much time. It is very much time consuming, and getting the data again from hard disk will take again a lot of time. Retrieving the data again, it is taking lot of time. That's the reason we started using Spark. Now understood why we started using Spark? You guys understood, right? Previously we were using big data and Hadoop. Okay, for Hadoop analytics we are using Hadoop and MapReduce for big data analytics. But Hadoop and MapReduce was going costly. It was taking lot of time consumption to load the data, and data retrieval is also taking lot of time. Okay, and also lot of skills is needed because that technologies are very deep dive. Okay, so in order to save the cost, in order to save the time, we started using Databricks. Spark frameworks is basically a Hadoop ecosystem, and Spark is 100 times faster than MapReduce. Bah. See what it is saying? Spark is a 100 times faster than MapReduce. Spark is not meant for loading the data, it meant for doing the transformations. Okay. Spark is meant for transformations like MapReduce. So we use HDFS, and for underlying storage, we have okay many Hadoop based, HDFS based. We can use many things for Spark for loading the data, and for doing the transformation, we can use Spark, and it's much faster than MapReduce. Databricks is internally using Spark technology. Our Databricks internally using Spark technology. That's why we are saying here, okay, it is much faster than MapReduce. Spark itself is an in-memory computing framework, and if we are trying to load the data in the hard disk using Spark, then it is a way much faster than MapReduce. It is a way much faster than MapReduce. Okay, Apache Spark, if you see, Apache Spark is an open source distributed general purpose cluster computing framework. It's an open source distributed general purpose cluster computing framework. We can use Spark if we are at a point where it does not make sense to fit all our data on RAM, and no longer makes sense to fit all our data on local machine on a high level. It is unified analytics engine or big data processing, where with built-in module for streaming SQL, machine learning, and graph processing. Okay, we can do many things with Spark technology basic here. Basically, Spark is one of the latest technologies that is being used to quickly and easily handle big data and can interact with languages shells like Scala, Python, R, and SQL. That's true. Okay, when we are using Databricks, then Databricks we can connect to multiple APIs. We can connect Databricks to multiple APIs. Okay, what is the multiple APIs we can connect? Like Scala, Python, R, and SQL. Okay, I'll show you practically. I'll show you. This is the architecture diagram. This is the architecture diagram. If you see here, we are having what a driver program, worker nodes. Okay, we can have multiple worker nodes in our Databricks architecture. In our Spark architecture, we can have multiple worker nodes. We can have multiple worker nodes, one driver program, and one cluster manager. One cluster manager. Okay, and worker nodes is having multiple components. Okay, to process, to load, to fetch, okay, to execute your data. It is having task, cache, and executor. We are having here Spark context, cluster manager. See, it is all two-way connected. It is all two-way connected. Driver program is connected to worker nodes. Worker node is connected to driver program. Okay. Driver program is connected to worker node. Worker node is connected to driver program, and executors means what? The internal components of worker nodes is having two-way connection with our cluster manager. Okay, cluster manager. See, if we see above Spark architecture, we have a driver program and multiple worker nodes. We have a driver program and multiple worker nodes. We can have many worker nodes in Spark architecture. We can define these worker nodes while creating a cluster. Here, driver program will talk to worker nodes, and once we submit the job to driver program, then driver program will submit the job to all the worker nodes inside the cluster. So this is I'm explaining the working functionality here. I'm explaining the okay working process of our Databricks, how it works. Databricks, how it works, how the internal components will work in Databricks. I'm explaining the okay theoretical part here. So what I'm saying is, see here, driver program will talk to worker nodes, and once we submit the job to driver program, then driver program will submit the job to all the worker nodes inside the cluster. In worker nodes, we can see multiple components like cache, task, executor, etc. And the actual task is performed at executor level. We can see in worker nodes. Yes, the actual task is performed at executor level. We can see that it is existing, it is residing in the worker nodes. It is placed inside the worker nodes. We have an executor where we perform our task. Once we submit the job to worker node, then driver will submit the job to all over worker nodes inside the cluster. And cluster manager, okay, will do the resource handling. And the cluster manager, okay, will do the resource handling. Okay. We can have multiple work cluster managers in Apache Spark architecture. Yes, we can have multiple cluster managers also if required, depends upon. Okay, this cluster manager will do the resource handling. Whatever the worker nodes needs all the resources, then cluster manager will provide to the worker nodes. Whatever the okay components, whatever the things required by worker nodes, that will be provided by cluster manager. Cluster manager will provide it to the worker nodes. If you want to talk Hadoop related, or if you want to talk, if you want to use only Spark related frameworks, okay, or if you want to use Spark standalone cluster and other cluster managers, okay, like Mesos, Kubernetes, these are also the cluster managers. These are also the clusters like Databricks. Okay, different clusters that Azure will provide. For DevOps engineers, they use Kubernetes clusters. For data engineers, we use Databricks clusters. Okay, so different cluster managers in the market where we need to handle the resources handling. Then these cluster managers can do the needful. The clusters manager can do the needful. The further information we can get it from the below link. From this you can get the link about the different cluster managers. What are the different clusters are available for cloud platform? For cloud platform. Okay, fine. So in Spark architecture, we have driver program, driver node with multiple worker nodes. Okay, in Spark architecture, we are having driver program, driver nodes, and multiple worker nodes. Once we submit the job to driver program, then driver will submit the job to all over the worker nodes inside the cluster, and actual task is performed at executor level. And once the task is done, then the result will goes back to the driver program. Guys, I will show you the practical. No need to worry. I'm also going to show the practical also. This is just the introductory part or theoretical knowledge I'm giving. No need to worry. Labs also we are going to do for Databricks. Okay. Spark basically carries master and slave architecture. That's true. If you see here, this is master and slave architecture. This is master, this is slave. And in between master and slave, we are having cluster manager, which is completely handling the internal components of the worker nodes to work about Databricks. Okay. interface smoothly. Okay, so it carries master and slave architecture. When we have one master node and all metadata information, we have slave architecture. Even in Hadoop also we have name node and different data nodes also. Okay, the Spark follows the master-slave architecture. Clusters consist of a single master and multiple slave. The Spark architecture depends upon two abstractions, that is RDD and DAG, resilient distributed data and directed acyclic graph. Okay. The Spark architecture consists of single master and multiple slaves based upon the volume of the data and workload. We can configure the Databricks cluster. Depends upon the data. We can configure the Databricks cluster. How we can configure? We can keep one master node. We can keep multiple slave nodes, or we can keep only one slave node. Okay, depends upon the data. We can keep multiple worker nodes also, slave nodes. Depends upon the data, how much volume of data we are having. Okay, we can specify maximum of 12 worker nodes based upon the workloads for you to do the transformation. How many? Maximum 12 worker nodes. Guys, see, this theoretical information is helpful for interviews point of view. This theoretical information is helpful for interviews point of view. So please read this theoretical information and keep it in your head. This should be in your head compulsory. Then only you can speak up in interviews. In interviews, they will check your theoretical knowledge only. They will check your concepts only. Please understand. Okay, fine. So we can specify up to 12 worker nodes based upon the workloads for your, okay, for you to do the transformation based upon the volume of the data and based upon the workloads. We have to choose all these things while creating a Databricks Spark cluster. Okay, these all things we have to decide when we are creating a cluster, when we are creating a Databricks cluster. And the Spark architecture depends upon the abstraction, how much we are considering. Okay, like RDD and DAC. Okay, directed acyclic graph. This is all theory, guys. This is all theory. In Spark, resilient distributed dataset is mainly used for loading unstructured kind of data. When we have unstructured data and we want to convert to schema, and we need to convert to the structure again. Okay, the RDD, resilient distributed data set, RDD. Okay, are the group of data items that can be stored in memory on worker nodes here. Resilient restore the data on failure. Distributed data is distributed among different nodes, dataset groups of the data. I'm just explaining the three different parts. Okay, what are the Spark components we are having? Okay, Spark SQL, structured data, Spark streaming real-time data, Emblip machine learning, graphics processing. Okay, fine. Spark core. Okay, the Spark core is the heart of Spark. It is the heart of the Spark and performs the core functionality. It holds the components for task scheduling, fault recovery, interacting with storage system, and memory management. Okay, Spark core is performing all these duties. It is performing all the duties in the Databricks architecture. Spark SQL, these are the points for Spark SQL. Spark streaming, these are the points for Spark streaming. Emlib, okay, fine. If you are trying to process some machine learning kind of activities and all, then it is eligible for even for that also. It is carrying an Emblip. Emblip is a machine learning library. It's a machine learning library that contains various machine learning algorithms. This includes correlation and hypothesis testing, classification and regression, clustering, principal component analytics, etc. Graphics. This is all theory, guys. This is all theory. Okay. RDD is the Spark core abstraction. It is a collection of elements, partitions across nodes of the cluster so that we can execute, okay, various parallel operations on it. There are two ways to create RDDs. Okay, this is what all the theoretical information. Azure Databricks It is an industry leading cloud based data engineering tool used for processing, exploring, transforming big data, and using the data with machine learning models. It is a tool that provides a fast and simple way to set up and use a cluster to analyze and model of big data. In a nutshell, it is the platform that will allow us to use Python, PySpark. Okay. See, Databricks is built on top of Spark technology. Databricks is built on top of Spark technology, and inside this Databricks framework, Databricks interface, we are writing Python commands. We are writing Python commands. That's why we are calling it as what? PySpark. That's why we are calling it as what? PySpark. The collaboration of Apache Spark and Python. Okay, we call it as what? PySpark. Databricks is built on top of Spark technology, and on top of Databricks interface, we are writing Python commands. Okay, because of this combination, we are calling it as what? PySpark. Okay, fine, guys. Is that clear? Azure Databricks is a data analytics platform optimized for the Microsoft Azure Cloud Services platform. Features of Azure Databricks: it can process large amount of data with Databricks, and since it is part of Azure, the data is cloud native. The clusters are easy to set up and configure in Databricks. It has an Azure Synapse Analytics connector as well as the ability to connect to Azure Databricks. It is integrated with Azure Data Factory. It supports multiple languages. These are all the features. These are all the features of Azure Databricks. Okay, why? It supports multiple languages. You can work in Azure Databricks with SQL, with Python, with R programming, and even with Scala. Okay, if you don't know Python, if you don't know R programming, you know SQL, that is fine, more than sufficient. If you know Python, if you don't know SQL, if you don't know R programming, that is fine. You can work with the Python. So it is giving you multiple options. I'll show you practically also. I'll show you. No need to worry. Azure Databricks is also an ETL tool where we can extract the data from sources and load it into the target. Load it into the target. Okay. One important note, guys. One important note. Always implement Azure Databricks and cluster in Azure paid subscription, because in free trial the Databricks cluster are not supported. Okay. So in free trial the Databricks clusters are not supported. Then the people who are not having paid subscription, okay, the people who are not having paid subscription, how they are going to do the practice? For them, we are having one community edition. I'll show that also. I'll show even that also. See, I'll tell you. Azure Databricks. Okay, what I'm saying here, see, Azure Databricks, okay, will not work in Azure free trial subscription. Azure Databricks will not work in Azure free trial subscription. Okay, so it will work in Azure paid subscription. It will work in Azure paid subscription. Okay, so now students are not having Azure paid subscription. Then how they can do the practice? So for this, for this, okay, I will show the Databricks in community edition. I'll show this in community edition, In community edition, Databricks work for free of cost. Okay. In community edition, the Databricks works free of cost. Okay. The Databricks works for free of cost. Okay. I will show the Databricks in community edition. The Databricks work for free of cost in community edition. So students can practice in community edition. Step by step, I will show. No need to worry. Step by step, click by click, I will show. Okay. So just for your knowledge point of view, I have given this point. I'll show the Databricks implementation in Azure portal. Okay. Also, I will show the Databricks labs. Okay. PySpark commands, Python, everything in community edition. I'll cover both. I'll cover both. So this is what implementation steps of Azure Databricks. Implementation steps for Azure Databricks. I'll take up this in tomorrow's class, guys. Okay. Practically, we'll see this in Monday's class. I'll see this on Monday's class. Okay. Fine, guys. Is that clear? All right. Is that clear? Is that clear, guys? Yes. What example? Jitendra, is that clear? Okay. All right. See, guys, actually, what is happening here, I told yesterday also, again, I'm telling. See, I'm seeing this screen. I'm seeing this screen, or I'm seeing this screen. So if you put any comment, I could not able to see in the chat. That's why it is taking little late time for me to respond. In Zoom, when we had classes in Zoom now, immediately I'll get a pop-up in the Zoom, one notification in the chat. But here in WebEx, it is not showing any notifications in the chat what you guys are putting. That's why it is taking little late time to me to respond. Please don't mind. Okay. All right, guys. That's it for today's class. If there is any questions, okay, please let me know. I'll answer your questions. If there is no questions, then we'll close.